Hi everyone, good afternoon. Thanks for joining us. This is Eli Singer. I'm CEO of JETRO Data based in New York. And what we want to cover today is the main topic is running BI on Hadoop and how to deal with the different performance challenges and how JETRO specifically is trying to address them. Starting with BI on big data, what are the trade-offs or building trade-offs? We'll talk specifically about SQL and Hadoop tools, some of the tools that people are using in the market today. We'll go through a live demo showing Tableau application running on a large data set in Hadoop. We'll show it in JETRO, in Impala, and in Redshift. And then we'll dive into JETRO technology in more details. If you have questions, if you don't mind just typing them into the chat box, we'll try to answer them as we go. We'll probably take about 25 to 30 minutes for the presentation, and that will leave us another 15 minutes for Q&A. So let's get going. A few words about JETRO itself. We are focused on one problem, which is accelerating BI performance on big data. This is the only use case we are focused on. So if you're looking for machine learning or predictive analytic performance and things like that, this is not JETRO. We are focusing only on the BI use case and only on performance. Technically, what we do is we have a server that sits between your BI and your data sets in Hadoop. And what this server does is provide full indexing and caching of the data. You can think of JETRO as a combination on the one side of columnar SQL database, like a Vertica or Teradata or Netezza, and then on the other side, a full indexing mechanism like Elasticsearch. So on the outside, JETRO looks like a SQL database. On the inside, it's fully indexed search engine. We are targeting the entire range of BI use case, from reporting to dashboards to discovery and ad hoc. And we work very closely both with the BI vendors and the Hadoop vendors. JETRO is certified and compatible with every Hadoop platform out there. Typically what we see, what probably 90% of the BI use case is BI tools that are doing extract of data from the various data sources, loading it into memory, and then running the analytics on that memory data set. This works great for data sets that are limited in size, depending on your hardware and how wide the table is and the different BI tools that you have, but several hundred million rows is typically the limit of this approach. When your data set is too big to fit in memory, then what typically happens is instead of bringing the data into the BI tool memory, we reverse course. We push out the queries from the BI tools into the target database, so in this case into SQL in Hadoop. The benefit of this approach, of course, is that we don't have the same size limitation that we had before. The negative aspect here is that we now replace in-memory performance with the target database performance. And when it comes to large data sets in Hadoop, it's typically much, much slower than what customers or users are expected or used to from their in-memory. This is not a new technology or not a new approach. We've been doing live access to databases for many years. What's new nowadays is that instead of connecting to a high-end, high-performance appliance, we're connecting to a Hadoop platform. And Hadoop, like any technology, comes with its built-in trade-off. On the plus side, we get the scale and we get the cost down for storage. What we pay for is performance. Now, this is typically not a big price to pay for workloads like ETL or predictive analytics, some kind of reporting. But that limitation, that trade-off becomes very visible and very limiting when we try to point our BI tools at Hadoop. When the user's using a visualization tool, pointing it at a large data set in Hadoop, and every time they click any option on the screen, they have to wait long minutes for response to come back. Here is a list of what we found people in the market do when their BI on Hadoop is simply too slow. The easiest thing and the basic thing to do is, of course, throw more hardware at your Hadoop cluster. Hadoop is great at scaling out. If something takes a minute and you have 20 nodes, make it 40 nodes, only going to take 30 seconds. Unfortunately, that's not a long-term solution. We cannot just keep throwing more and more hardware at it. Another thing people are often trying is different SQL tools. So if Hive on MapReduce was too slow, we can try Hive on Tez, or Hive on Spark, or Impala, or Drill, or Spark SQL, and many of the other tools out there, trying to see if any of them will be faster than the other ones. When that approach doesn't work, what people typically do is give up some of the flexibility of the data model, go back to the rigidness of the EDW of the past. So what we see here is people typically have much less granularity of the data, or do some pre-aggregation. There is a resurrection of the OLAP cubes a few months ago, became available in the market. We see people changing the entire data model, trying to denormalize it into a single table, replicating the data with different partition keys and so on. So the long list of things we've been doing for many years, trying to speed up EDW. Then we could jump to the completely other dimension, which is if Hadoop is just not going to be fast enough for BI, the alternative is to put a faster analytical database next to Hadoop, something like a Teradata or Vertica or Redshift or BigQuery, and then copy data from the Hadoop cluster into this EDW system once a day, once an hour, and run BI on that. And then, of course, we have the give up on Hadoop and give up on SQL altogether and try new things like Elasticsearch and Kibana, or put all the data in a NoSQL database and do some reporting of that. So that's the range of things people have been trying out there. But obviously, the underlying problem is SQL on Hadoop. If we can make SQL queries on Hadoop much faster, then BI would work much faster. Now, the challenge with the different SQL and Hadoop tools out there is essentially architecture. Every single SQL and Hadoop tool that we know of, from Hive to Impala to Presto to Spark SQL and so on, is using the same architecture. They're all PP full scan architectures. Now, to explain how that works and what the challenge is, let me use this analogy of a huge library that has billions and billions and billions of books. And then we organize those books into recs, thousands of recs, and we put a librarian on each one of those recs even. And when then somebody walks into this library and asks for the list of books by Stephen King, what would happen is that each librarian will go to their rec and pull out book by book by book to see if the author is Stephen King. Now that, of course, is extremely wasteful and slow when you have a huge data set and your query is selective, looking for a small subset. That is the challenge of full scan architecture for BI use case. What we are doing in JETRO differently is, instead of being full scan based, we are full index based. We index every single aspect of the data, every single column. And when we get this query, it's a much easier process. We just go to the index for author, go to the entry for Stephen King. It tells us you need to get books 1, 5, 10, and 20. And we just go and fetch those books. And that's how it works much faster for selective BI queries. So if you want to understand how JETRO works, here is a simple diagram. We have the BI tools on top. The BI tools connect to JETRO via live database access. In Tableau, it's known as Live Connect. With Qlik, it's known as Direct Discovery. And different tools have different names. But the BI tool would send queries directly to JETRO. When JETRO receives a query, it would use multiple performance features. The first one is indexing. As I mentioned, we index every column, so we can use the indexes to narrow down the number of rows that we need to fetch for this query. Another performance acceleration feature is caching. JETRO caches query results of prior queries, and if a query is repeated, then the result is going to be fetched directly from the cache. And then JETRO generates dynamic aggregations. If it realizes that some query patterns repeat themselves, JETRO would automatically generate an aggregation similar to a roll-up cube, if you will, and then be able to serve queries of that aggregation automatically. Everything JETRO has, all this data, the cache and the aggregations and the index and the column files and metadata and so on, everything is stored in HDFS. None of it is stored locally within JETRO. Now, what we did here is to show a benchmark, trying to compare the performance you would get from JETRO to what you would get from other tools. The way we approached this, we took TPCDS dataset. TPCDS is an open source benchmark. We generated a 1 terabyte dataset. The fact table has about 2.9 billion rows, and there are 7 dimensions. And then we took this table and we have it in 3 different formats. One is in Parquet format, and we have Impala running on top of it. One is in JETRO format with JETRO, and we also put it in Redshift just to get some reference performance points. Everything is hosted on Amazon, so what you can see here is the hardware setup and the hourly cost. JETRO costs about 75 cents per hour in this setup. Impala costs about $5, and Redshift is about $1.50. Now this benchmark is publicly available, tableau.jetrodata.com. You can log in with user demo and password demo. You can also see the Qlik demo. It's jetrodata.qlik.com. And let me go and show it to you live right now. So I already logged in and accessed the JETRO dataset. We have the same exact application for Cloudera Impala. As you can see on the top left, there are 2.9 billion rows right now being used for this dashboard. And what I'll do is what users typically do. I'll just start drilling down. So in this case, we'll go to the filter of year and choose year 2000. I'll go and choose year 2002. And what happens now is Tableau issues about 6 or 7 SQL queries. In this case, they're being sent to Impala. And Impala would go and do a full scan of this data set to fetch all the data and reply to the user. Let's do the same thing on the JETRO example. Choose year 2002. And the response here is quite instantaneous. As you can see, we already got a response. We can then go and drill down, choose a category, say electronics. Again, fairly instantaneous. Click on West Virginia, I guess, as a state. Response time for JETRO is anywhere from 1 to 10 seconds or so. And as you can see on the top left, at this point we are down to 1.7 million rows. So JETRO only had to go and fetch 1.7 million rows out of the 2.9 billion. And this process can continue. You can continue drilling down and see how it works. If we go back to the Impala example, we are still waiting on the first filter. It takes about 1.5 minutes plus for Impala for any interaction. So I won't bore you with waiting for this to come back, but as I said, this is publicly available. You can easily go and play with it yourself. If we go back here, this is a graph showing the average response time for a dashboard refresh. What we did is we took this live benchmark that I showed a few seconds ago, and we timed different operations, getting the initial starting page, the main page, and then how long does it take to run it with 1 filter, and then 2 filters, and 3, and 4, and 5, and 6, and so on. What you can see in JETRO is that many of the initial queries, the main page and the one with a single filter, typically get replied out of cache. That's because those queries are fairly generic and high-level queries. So once a user ran them, then subsequent users will get it for free. And as queries become more unique with more filters, JETRO ends up going to the indexes. But then again, we have very filtered queries, so response time is pretty consistent. On average, response time in JETRO is about 6 seconds. With Impala, what we see is the initial page takes quite a bit of time. And then when we start filtering, we see a reverse phenomena. The more filters you add, the slower the query gets. The reason for that is that every new filter actually requires another column to be scanned, a column that we did not have to scan earlier. And average response time is about 1:32 seconds. So this is really the bottom line. If users can wait 1.5 minutes per interaction, then life is good. And if they need something much faster, then an acceleration server like JETRO can provide this type of performance. Let me now switch into talking about how JETRO works and what is the architecture behind it. The first step, and probably one of the most important things to understand here, is that JETRO, again, is only meant to be used for BI use case. And what you should think about is your BI-worthy data sets. Not everything in Hadoop has to have JETRO on top of it. You would only use JETRO for those BI-worthy data sets. Now let's assume we already have a Hive or Parquet table in Hadoop that we want to expose to our BI users. What you will do is you will take this data set and pass it to JETRO for indexing. JETRO will read it from Hadoop, create an index version of that table, and then store it back in the same Hadoop cluster. The process is pretty efficient. We can index about 1 billion rows per hour on a regular, let's say, 30, 40 column type table. And the important thing is that once you've done it for the initial table, let's say we took the last 2 years of data and we had 5 billion rows, and that took a few hours to do, from that moment on, you can incrementally send data to JETRO. It can be once a day, or once an hour, or every few minutes. And JETRO knows how to get this incremental data and incrementally update the index version of the table. Once we have the data in Hadoop, the index version of JETRO, it is just spread across the cluster like any other file in Hadoop. JETRO Query nodes run as an edge node. You do not install JETRO on the data nodes in the cluster itself. JETRO runs as an edge node. It connects with the cluster via HDFS client. You can have one JETRO node, or you can have multiple JETRO nodes, depending on how much concurrency and load you have on the system. When JETRO gets a query, summarize sales, where product is books and state is New York, what we do is we first go to the workloads, go to the index of those two filters. We go to the index of product, to the entry books, and get the list of row IDs that have the value books. Do the same thing for state New York. And the result is we have the list of row IDs that we actually need for this query. Then we go and we fetch the column data, but only for those rows. We don't have to fetch it or scan column data for rows we don't need for this query. We do the aggregation and we apply it back to the user. The important thing about this architecture is that the performance of a query really depends on how wide this query is. So if this query, let's say, touches 10 million rows and it takes 10 seconds to run it, it would take the same 10 seconds to run if the data set has 1 billion or 10 billion or 100 billion rows. Performance is not affected by the size of the data set, only the size of the working set, the actual rows needed for each query. And that is pretty much how users expect it to be. When they run a query that's supposed to touch a lot of data, they expect to take longer than a very narrow query that just touches a small subset. A few words about our indexing technology. That's obviously one of the biggest parts of our innovation. We index every single column. The indexes themselves are in form of inverted lists. So it's the list of existing values, and for each value, all the different row IDs that have that value. We have a lot of optimization about index access. We actually have a lookup table or an index of an index. So when your query looks for a value France, we don't have to scan the entire index. We use this lookup table to locate the exact offset of that value and can go to there directly. That means that we don't need to keep the index in memory or things of that nature. Next important thing to understand about our indexing is how we handle updates. Traditionally, when you index columns and the new data arrives, you have to go and update the index. And when you do that, you have to log the index, and that's affecting performance of reads, and that becomes a big mess when we talk about large data sets and indexing of every column as JETRO does. So what we did here is a different architecture. Instead of updating the index, when new data arrives, we actually append the index, even if it means duplicate entries. Now we can deal with those duplicate entries because we have the index of the index, so it's fast to find them. And then there is a background process, completely offline. When the index becomes too fragmented, it would automatically read those fragments, create a merged version of the index, and then swap it back in the Hadoop cluster. So that's JETRO indexing technology. It's really very useful for drill downs, for discovery, where queries can come in any form or shape, where users want to have the flexibility to filter on any column, regardless if it's a partition key or a sort key or anything of that nature. The next key feature of JETRO is our caching and aggregation. Now, the key here is when you have dashboards and BI reports, a lot of queries tend to repeat themselves. So when a query is being received by JETRO, we will take the results out of this query and cache it, store it back in HDFS. We don't have to store it locally, so there is unlimited storage for it. It works quite nice because many of the high-level queries, the ones that have very few filters, tend to be easy to cache because they are very repeatable. And as query becomes more and more unique because there are more filters, it's more hard to cache them because they're quite unique, but then the indexes kick in. So between the caching and the indexing, we have pretty good performance across the entire range. One more important feature here is our automatic aggregation. When we realize, when JETRO realized that some query patterns repeat themselves, JETRO would automatically generate an aggregation, something similar to a roll-up cube. It's done automatically, it's internally, it's hidden from the users, it's used essentially for performance acceleration. And JETRO can create thousands and thousands and thousands of those. We keep them very small, we store them all in Hadoop, so there's no size limitation about them. Importantly, when new data is being added to the data set, we do not invalidate this cache. When a query is repeated and we realize more data was added, we will run that query only on the incremental portion of the data. And we'll take those results and merge it with the stored results from earlier for the updated results. So this way the cache is proactively being maintained and can be used across many loads. I'm not going to get into this slide, just to explain the high level. It explains how JETRO identifies repeat query patterns and builds an aggregation. The most important point about it is that we only build very small aggregations, very narrow ones. Queries that have a lot of different filters do not need an aggregation to be accelerated. They're being accelerated through the indexes. So again, we have these very nice complementary capabilities here. A lot of columns that would otherwise create a very large aggregation are not required because we can use indexes. But for very shorter queries with very small number of columns, then the aggregations provide great benefit and end up taking very little space. So here is just a summary diagram of how the entire thing is being put together. We have the BI tools on top. They connect to JETRO via ODBC or JDBC. JETRO servers running as edge nodes. You can have one or many of them. JETRO servers are fully stateless. There's no data that they own locally. Everything that JETRO has is stored in HDFS. And within HDFS, of course, we have the tons of different data sets that you have. There are those few BI-worthy data sets that for those we created an indexed version in JETRO that is stored as well in HDFS. So that's how all the components play together. And as a quick summary, the focus of JETRO is to provide limitless BI on big data, the full range of use cases, from reporting to dashboards to discovery to ad hoc. And we use the two main capabilities. Indexing help with interactive discovery and fast drill downs. We don't have to read unnecessary data. And then the aggregation and the cache enable interactive dashboards and fast reports because a lot of those queries repeat themselves. And we wrap it all with incremental refresh that allow you to update your data every few minutes so you can get as close to real time as possible. Lastly, JETRO was meant to be evaluated, self-evaluated. You can download JETRO from our site. What we typically recommend to do is to have a POC review session with us where we can actually review what you plan to do, what the data set is, the complexity of the schema, what is the application. We can give you some pointers to best practices and some assessment. And then you are off to the races. Index a couple of data sets, point your BI tool, and run your queries. So with that, I'd like to open it to questions. And see if anybody would like to no, everybody's on. It looks like we'll have to do questions via the chat box. So if you can type in your questions in the chat box, that would be a way for us to see them. Hmm? So one question I see here is about JETRO Query nodes and where they are placed in the system. So JETRO Query nodes are installed as edge nodes. They are connected to the cluster via HDFS, but you do not need to install JETRO inside your data nodes themselves. And a follow-up question to that was about hardware. Typically, JETRO Query nodes use, I guess, a compute type hardware. We recommend 128 gigabytes and about 16 cores of data. We've had people run JETRO with less, but the more compute power you give JETRO, the faster it will get. I see a question about SQL compatibility. JETRO is SQL 92 compatible. We support pretty much everything that BI tools can send our way. The main SQL feature that JETRO currently does not provide is window functions. But your typical subqueries, joins, group bys, and so on, everything like that is supported. Another question I see here is about JETRO licensing. We actually have JETRO pricing on our site. We price and license JETRO by JETRO Query nodes. So we don't charge based on how much data you have, and we don't charge based on how many Hadoop nodes you have. It's really about how many JETRO Query nodes you have, which is a function of concurrent users. I see another question here about comparing JETRO performance to EDW tools like Netezza or Teradata. Our reference test is basically SQL and Hadoop. That's what we built JETRO to do. We have quite a few customers who are comparing JETRO to EDW systems like Netezza or Teradata. And I can say that in most cases, JETRO is at par, and in some cases even faster. The main reason is that JETRO is fully indexed. Every column is indexed. So depending on the queries, if a query that you run to JETRO is not based on a partition key or sort key, JETRO would perform faster than say in a teaser or another tool. We will definitely publish the presentation and the recording for your reference. I see a question about JETRO running on a cloud. So JETRO is downloadable. You can run it on premise, you can run it on the cloud. The demo that we showed is running on Amazon. We actually have an Amazon AMI that's already pre-configured with JETRO, so you can run it there. Currently, JETRO stores its data in HDFS. JETRO can also store its data in other file systems. We support essentially any POSIX system. We can store data on a local file system, a network drive, and we can also store data in Amazon S3. So you can have your data stored in S3 essentially. There's a question about scalability, a couple of questions about scalability. And the answer here is that JETRO is fully elastic. You can add as many JETRO servers as needed. All of those servers essentially work directly on the same data set in Hadoop. And the way it works is that JETRO ODBC client and JDBC client was just round-robin queries between those servers. So the more users you have, the more concurrency you have, you just add more JETRO servers to support it. There's no architectural limit for JETRO servers or JETRO sessions. There's a question about, a couple of questions about indexing technology and performance. As I mentioned, the indexes are appended, and that means that there is no locking in the system. So when new data is being added, it does not affect performance of existing reads. It's also important to explain that JETRO was designed for an append-only scenario. So data is added. All data can be purged. JETRO supports partitions, so you can use partitions to purge all data. But you cannot do updates in place in JETRO. There's a question about BI tool compatibility. We work via ODBC and JDBC. Been testing extensively with Tableau and Qlik. Have done some testing with Microstrategy and Jaspersoft and business objects, and all of those been working well with JETRO, so we assume that other tools would work as well. Sorry, kind of jumping between questions without a specific order. There's a question about the underlying data, for the raw data format for JETRO indexing. So as you choose tables to be indexed, JETRO essentially can read delimited text format, something like CSV. What we have some people do when they have their data in a, say, Parquet format or something else, is to essentially do a select star using a Hive or Impala from their existing data set and then pipe the output into the JETRO loader. So you select from your existing source, pipe it into JETRO. JETRO creates this index version on the fly. One way to think of it is to, I guess, compare it to an extract that you would do with a BI tool or with an ETL tool like an Alteryx. There's a question about JETRO and streaming data. Right now, JETRO supports micro batches. We say that you can probably push data to JETRO up to every minute. The main reason for that is to avoid very small fragments. We have not yet integrated JETRO directly to a streaming messaging bus like a Kafka, but it's a fairly thing for you to do from an application perspective. So JETRO can receive data live via pipe, and we configure JETRO to do microload, so we end up having some kind of scale in terms of our data being loaded and not having to load every single row separately. There's a question about Hadoop hardware. Would SSD improve performance of JETRO? The answer is not really. The entire idea of the architecture of JETRO was to be surgically accessing data on the Hadoop cluster. So we essentially talk to HDFS, open a file, stick to the position that we know our data is there, and just read the bytes that we need to. So because JETRO is so I/O efficient, you actually do not need to optimize your Hadoop hardware. You can use basic Hadoop setup. I would even say more than that. Unlike requirements of tools like Spark or Impala and so on, from JETRO's perspective, your Hadoop data nodes can have minimal hardware. They can have 4 gig of RAM and four cores. There's no significant improvement of performance if your Hadoop hardware is greater than that. There's a question about APIs into JETRO, and at the moment, the API that we support is SQL, so we don't support any other communications. We do, as I said, SQL 92, fairly complete, and we extended a lot of administrative functions can be done via SQL. So, for example, you can run a query that says show active queries, and to return the list of currently running queries in the server. So SQL is the main API for JETRO. Let me see if we missed any other question. There was a question about window functions. It's definitely the roadmap, probably later this year. I cannot give you a direct time for that. There was one more question I missed from earlier about indexing, and the answer here is that indexing is done automatically for every query, for every column. So there's no need for DBA to choose which columns are more popular or more important. We index every column, and the main reason for that is that BI tools nowadays encourage users to explore and discover, encourage users to customize and build their own reports. So we wanted to make sure that whatever columns they choose, the performance was always going to be aided by an index. So that's why we just went with full indexing. There's actually no way to tell JETRO not to index a column. And I think, let me see. There's a question about some use cases and verticals, so that's a good point that let me add some color around. The most common use case for JETRO would be BI data sets that on the one hand are just too big to be loaded to memory, and on the other hand are too slow to access at the target database. So you have that dilemma of this data set. You cannot bring it in, and when you connect to it live, it's just too slow. That would be the most common use case for JETRO. In this case, you would load it to JETRO, index it, cache it, and the BI performance is going to be much closer to in memory than you would get with a typical analytical database. Size-wise, I would say that we see most of our customers having data sets from few hundred millions to several billions, probably 5-10 billions would be the range. The largest JETRO installation has a BI data set of about 100 billion rows and several dimensions connected to it. That data set has about a daily growth of 1 billion rows, and it keeps the last 90 days of granular data, and then data is being rolled up. The use case for that scenario is another interesting use case that might apply to some people here, and that is what we call multi-tenancy BI. Think of a cloud company or service provider that has hundreds of thousands of clients and they want to provide BI reporting to that large audience. Typically, you would have one data set that has the entire reporting data for all of your clients. And it really makes no sense for each of the clients when they run a query to do a full scan that touches everybody else's data. So traditionally, the way it's being handled is via partitions. But the challenge is that if you have a large number of clients, let's say 10,000 clients, and then you also want to have daily partitions, you end up with millions and millions of partitions, and that's not really very effective or efficient. So JETRO is a great solution here. You use indexing to separate between those different clients. Every query has a client ID filter to it. And that means that if you have 1,000 clients, every query starts by filtering out 99.9% of the data right off the bat. So that's a great use case for JETRO indexing when you have a large data set and multiple clients sharing it. The question about comparing JETRO to Spark, and the answer here is that Spark by itself, of course, is not a SQL engine. Spark SQL is a SQL engine. And in many ways, Spark SQL is not different than a Presto or Impala or Hawk or any of the other SQL engines on Hadoop are. All of those tools will do better if you give them a lot of hardware. If you give them more memory, they can cache more things in memory, they'll be much better. JETRO took a completely different approach. We don't rely on storing everything in memory, we rely on pre-indexing. So when we pre-index the data, then when we get a query, we can filter it significantly right off the bat again. And that's the main difference in architecture. So I would say JETRO is not a replacement for Spark SQL or Impala or Hive. JETRO is really optimized and focused on the BI use case. For that, indexes would work much, much better. The other tools like Spark SQL and Impala, for example, will do a much better job than JETRO at predictive analytics or your ETLs or machine learning and so on. So use the right tool for the right use case. But we have not seen Spark SQL performing any better than all the other tools. It's still a full scan MPP at the end of the day. There's a question about Power BI. We definitely intend to integrate with Power BI. The main limitation there is that Power BI right now has a live database access to a very small number of databases. As soon as they add a generic ODBC driver for Power BI, then JETRO will integrate with it. I might be behind you, maybe they already published something like that, but last time we checked a few months ago, they did not have a generic ODBC integration. So once they do, we'll definitely support that. There's a question about indexing in Hive, and the answer is that yes, you can define indexes in Hive. These are typically static indexes, so they don't incrementally get updated, and it's certainly not full indexing as JETRO does. So the concept of indexing is not something that JETRO invented, obviously, and it's not something that we are the only ones thinking about. The probably important thing about JETRO's approach is that we really took it to a point where it's fully indexed, every column is indexed, it's incrementally updated, and it's done automatically. So that's the unique aspect of JETRO indexes. There's also a question about HBase, and I guess I'll explain it to all the other NoSQL. We've seen people copying data from traditional Hive tables to an HBase, mainly because it gives them an index, essentially the key, which I understand is extremely valuable. We again took it much further than that and fully indexed it. So instead of creating an HBase with a single index or replicating into multiple HBase tables so you can have multiple indexes, with JETRO you just get all the indexes, full indexes up front. So again, just an architecture that's very optimized for BI use case. It's not that you cannot do other things trying to speed things up, just nothing will be as complete and as optimized for BI as JETRO is. All right, let me see what else I missed here. There was a question about stored procedures, and the answer is that we currently do not support stored procedures. There's a question about incremental updates. So let me explain it in a bit more details. Let's say we have an index and we already have, actually let me go to the slide that explain how it works, and I'll use that. So if we already loaded in this diagram the 10 rows, and we have an index for country, and we have the list of rows for each country, and then we go and we load the next 10 rows, and another France shows up. In traditional indexes, you will go to the first entry of France, go to the end of the list of row IDs, and stick in the new row IDs that just arrived from this new load. The problem with that approach is that it requires locking of the index. And when you lock the index, you affect the performance of everybody who's trying to read data right now. And when you have an index on every column, this could be extremely costly. So what we do in JETRO instead is we never update the index, we only append it. And in this case, what will happen is we're going to have 2 entries for France. It's going to be a duplicate entry. The way we handle that on the read side is that each of those index fragments have its own higher level index, an index of an index, if you will. So it's very easy for us at runtime to identify all of those duplicate entries and just merge them on the fly, or get union them on the fly, I should say. So that's how we deal with appending on the read side. On the write side, when the index gets to be too fragmented, there is a JETRO maintenance process that's continuously running. It has a definition of a threshold when the index should get remerged. And what happens is, let's say we have 20 fragments, this process will kick in, will read those 20 fragments and start merging them in the background. Now the good thing here is that it doesn't have to worry about that halfway through the process the index was changed and now it has to restart it. It can read those fragments and it knows for sure it never gets changed. Indexes are only appended. So this entire process can happen in the background without really affecting anything that's being read right now. And when we finished merging the index and we have a new merged index, we just drop it back into HDFS and flip a flag and say, here is the updated index. So this entire process, unlike I guess the firestorm or IO storms you have in HBase for compaction, or what happens in the teaser when it has to refresh all of its zone maps and so on, this process is completely offline. It doesn't really affect performance in any way. And last question, we're starting to run low on time here. Last question was about denormalizing data. So JETRO actually does not force you to denormalize. You can have a complex data model mapped into JETRO. We support it. We support a lot of join optimizations, and we even support join indexes. So you can define a dimension attribute as an index on the fact table. And when we get a query referencing that specific attribute, we actually don't have to perform the join. We can filter it on the fact table directly. So absolutely flexible in terms of complex data models and very optimized joins. And with that, I'd like to thank you all for joining us and for the great number of questions. We will post this session online. We will send you the deck of slides, and we would absolutely welcome an opportunity to have a direct discussion with each and every one of you. So thanks again and have a great weekend.